Good afternoon, everybody, and welcome to Creekside Elementary School in Durham, North Carolina. Creekside, I'm going to let them hear you for a moment, so let's say hello. Hello. Excellent. Now, Creekside knows something's happening today, very exciting, and I know you know that too. We are celebrating our 21st virtual field trip this year with Durham Public Schools. This is K-5 science, and we're doing a great job here. Teachers are amazing, and kids are learning. Today we are Skyping with NASA. Now this broadcast is coming from the Goddard Space Flight Center in Greenbelt, Maryland. And we are so excited about what's happening. For those of you that are watching on YouTube, if you will sign into YouTube with your account, a chat window will open up. You can send in questions. We have a moderator working on the chat window right now. She will take as many as she can get. She'll take them even better if you make sure you put the question, your name, and your grade. First names only, please. If you throw in your school, that's fine too. Today, we are going to be Skyping with Andrea, and she's going to introduce herself in just a moment. But she is in charge of all things about the moon. This is part one of two parts. So we're real excited to be here today. I'm going to start walking back to the cameras, and we're going to start working with our NASA people right now. So let's very quickly and nicely welcome our visitors here from NASA.
Thank you. So obviously I'm not Andrea. My name is Mark Branch, and I am here at Goddard Space Flight Center. I'm going to introduce Andrea Jones in just a second. I'm also an engineer, an aerospace engineer here at Goddard Space Flight Center. Been here for 25 plus years and have worked on the satellite that is bringing back brilliant science about the moon that Andrea is going to introduce, the LRO, the Lunar Reconnaissance Orbiter. Right now, though, we have a brief video that we're going to show you. So listen, look, and learn.
Time flows. Earth breathes. Deep space beckons. The Goddard Space Flight Center leads. 3,300 civil servants and more than 7,000 contractors lean into the future. In fact, we design the future. Robots repairing spacecraft? It's happening here. Precipitation research for global freshwater management and profound climate research. That's us too. The future is closer than you think. We'll take you there. The NASA Goddard Space Flight Center.
Hi everyone, my name is Andrea Jones, and I am not actually a rocket scientist, nor am I in charge of all things moon, but I do work with a lunar mission, and today I'm going to talk with you, if we can put my first slide up, I'm going to talk to you about the moon, which is a really exciting place right now. We are learning all kinds of new things about the moon because of some missions that have been up there right now and also have been up there in the past few years. And so I'm just going to let you know some of the science updates that we've had and also just try to get you excited about all the things that are coming out from NASA about the moon. So next, please. So before I talk to you about the moon, I just want to let you know a little bit about me. So I am a planetary geologist, which means that I study the Earth in order to learn about other planets, and I study other planets in order to learn about the Earth. And so this is really neat. If we see big volcanoes on the Earth, we can actually go there and sample them and find out what's going on, and then look for volcanoes like that on places like the moon or Mars or Mercury, and learn more about how all of our solar system objects, all the planets are connected, and also try to learn more about, how our Earth formed and how other planets outside of our solar system got together. And this is a picture of me in Iceland holding some bread that was cooked underground by the heat of the Earth, which as a geologist I thought was really cool. So next slide, please. So what do I do here? I'm actually a scientist, but I'm also an educator. So right now I get to do things that you can see up there, I work with the Mars Science Laboratory Curiosity rover. I go to places like Craters of the Moon National Park and talk to teachers about the moon there. I teach about phases. I work with in Death Valley National Park as well, and do a lot of cool things to share NASA science with different people. So those are just a few of the details of my job. Next, please. So I know that you all can't talk to me. I wish you could, but I want you to be thinking throughout this presentation about a few different things. So NASA went to the moon. We're there right now, but I want you to all just sit for a minute and think, why would we go to the moon? Why would anybody want to go to the moon? So you can mull that over, but next, please. Some of the reasons that NASA wanted to go to the moon or go back to the moon, or actually you can go back, were to really think about how, how are we going to learn about the rest of the solar system with the closest object that we can get to. So this is an Apollo picture, and you can actually see the Earth in the background there from the moon. And the reason that the Lunar Reconnaissance Orbiter was chosen was to really get ready for future humans to go back to the moon, for future astronauts. Since we launched, we've had a change in direction, and we learn more about science now. But that was still the primary mission motivation, to get ready for future explorers. So next, please. So we had to think about, okay, if we're going to go to the moon and get ready for future humans, what kind of information are we going to want to know? So this is another question for all of you. What would you want to know if you were going to go build a base on the moon or establish a settlement? What kinds of things would you want to know? So next. So NASA decided that some things that would be really important to know if you're going to go build a base on the moon would be to find out what the surface is like. What is going on with all the rocks, and where are the mountains, and what's the shape of the surface, and what's the radiation environment around. And that's a big way of saying, if you went up to the moon and you're in your spacesuit, what kind of protection do you need in order to not turn to goo or to fry or to freeze? We want to make sure that you're protected if you go to the moon. We also want to find out what kind of resources are there. Resources such as water, because there is actually water on the moon, and we want to know how much there is and where it is and whether we can use it. Also things like there are shelter areas on the moon, places that there are actually collapsed pits on the moon that you can crawl under maybe, and protect yourself from that radiation. And then we also want to find out, again, where the big rocks are, what's going to get in the way if we want to land. So those were some of the things NASA thought was important in sending a spacecraft back to the moon. And that spacecraft is the Lunar Reconnaissance Orbiter, which is right now, today, orbiting the moon. And if you went up to the moon right now and you lay down and you made a moon angel, it has a camera that could see you on the surface. That's how high resolution that image is. So next, please. All right, so launched in 2009 in June. It took about 4.5 days to get to the moon. I know someone had asked that question, so that's how long that spacecraft took. Other spacecraft can take different amounts of time. The Apollo missions took about 3 days to get there. New Horizons, a spacecraft that just flew by Pluto, I hope you all heard about that, only took about 8.5 hours to fly past the moon, but it went straight there. It didn't go into orbit, and so it went really, really, really fast. Next, please. So here are some of the things that we're seeing. Anyone know what we're looking at here? I hope you will recognize that that left image is the near side of the moon, and that right image, maybe you haven't seen this before, but that's the far side of the moon. And they look, I hope you can tell, really different. So we've got a lot more dark patches on the left. We've got a lot more white areas, light areas on the right. And next, please. These are the near and far sides of the moon. And one of the biggest mysteries about the moon is why these sides are so different. So that's still an unsolved mystery. Someone out there, one of you, could be the one to solve that mystery someday. Next, please. All right, what else are we able to see with our awesome cameras? Well, here's an image from the last time people walked on the moon. Next, please. These are astronaut footprints and traces of tire tracks the lunar buggies that were up with Apollo 17, which was there over 40 years ago now, and the last time people walked on the moon. So those are some of the details. Next, please. So we also are learning a lot about this really, really important feature on the moon. Anyone know what that is? That, next please, is an impact crater. So impact craters, if you're not familiar with them, they are places where big things from space come and crash into the moon, and they have a big explosion on the ground, and they cause rocks and debris to come up out of a big hole in the ground, and that becomes the impact crater, and then fall down. So we have ejecta, those bright streaks that shoot out from some of those circular features you might be able to see on the moon if you were to look up at it. Those are impact craters, and that's a really, really important feature on the moon. And we also have them here on Earth and on every other solid surface in the solar system. So learning about them on the moon helps us, again, learn about other places and processes that happen throughout our solar system. Next, please. All right, so that last image, if you'll go back one, that last image, this is Tycho Crater. So if you have looked up at the moon before, this crater is something you may have seen in the sort of bottom left of the moon on the near side. This is a very young crater. It formed around the time when the dinosaurs were here on the Earth. So if they looked up, they could have maybe seen this impact occur, which would have been really cool. But that mountain in the middle is called a central peak. And if we go to the next one, that little mountain that you saw before is right here. It's a little less than 5 kilometers, or a little more than 2 miles high. Next, please. And that little boulder, I'm going to let you all make another guess here. How big do you think that might be? Everyone think of an idea on that 2-mile mountain. That boulder right there is the size of a baseball stadium. Size of a baseball stadium, and it's sitting on top of a mountain that's 2 miles high. And we have no idea how it got there. When that image came down from the camera, all the scientists were so excited because it totally didn't fit. We weren't allowed to have a boulder that big on top of a mountain according to the way we understood impact cratering to occur. So it's changing the way we're thinking about these really, really important processes in the solar system by having pictures like that. Next, please. All right, this is kind of cool. You might not recognize this. It kind of looks like a spooky Halloween picture, but this is actually, next slide, light and dark areas on the south pole of the moon. So this is actually an image mosaic. It's not one, but it's 6 months of images from our cameras stacked one on top of the other, and every time there was a light part, there's a white pixel, and every time there was a dark part, there was a black pixel. And over time, this is how the places that in 6 months got light on the south pole of the moon and that didn't get light. And those dark areas, we call them permanently shadowed craters. And that's really important, and that's a really interesting part about the moon because they're really, really cold. So next, please. So one of the things that they can do because they're so cold is they can trap water. So those really dark blue, black areas that you see, this is also the south pole of the moon. It's a slightly different scale, but that's where we have water on the south pole of the moon. And we actually have water all around the moon, but just in different quantities. And here at the poles are some of the places that they're concentrated because it's so cold and so dark. Next. All right, because it's so cold and so dark, we have actually measured the coldest place in the entire solar system on the moon. It's in the south pole in a crater called Hermit Crater, and it's almost 250 degrees negative Celsius, which is negative 415 Celsius, which sounds maybe a little hard to comprehend, but it's really, 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 really cold. It's colder than Pluto. Pluto only gets down to about negative 300 degrees Fahrenheit, and the moon is negative 400 plus Fahrenheit. So it's a big difference. It's really cool that it's on the moon. Next. All right, so when we launched LRO, we had a sister spacecraft with it called LCROSS. So this spacecraft launched up to the moon in the same rocket. They orbited together, and then LRO kept spinning around and orbiting and finding out what was on the surface. And LCROSS did this sort of wiggle around and took a little longer. And eventually it crashed into the south pole of the moon in a place that our water detector had figured out was a place that had a lot of water in it. So next, please. So here's what happened. Something crashed into the moon, and there was a big explosion that made an impact crater. So next. And this is actually our thermal image. We could actually take an image with heat to find that little fuzzy patch. That's actually the impact plume, the dust and gas that came up from that impact. And so by actually sending something to crash into the moon, we were able to kick up some dust, kick up some gas, and find out what was in a permanently shadowed crater on the moon. And there's really cool stuff. Because it's so cold, it's trapped all kinds of interesting things, potentially for billions of years. And scientists are really, really interested in studying that. Next, please. And as I mentioned, actually, the last image was from our thermal imager. But here, LRO got to see it, which is really, really cool. So next, please. And I wanted to just leave you with a few really cool pictures. This is just down from the spacecraft. In December, we released this image. And this is our camera looking over on the side of the moon and looking up at, of course, the Earth. So this is our new Earthrise. Actually, it's an Earth-set type picture, just showing how beautiful it is from our spacecraft. So next. And I just wanted to let you know that because of the Lunar Reconnaissance Orbiter, because of LCROSS, because of some other missions that we've had up at the moon that we're studying the environment up there, we're preparing for the next lunar explorers. And that next person to step on the moon could be one of you sitting in that room right now. So I really, really encourage you to be thinking about, what is it that I want to know? How do I study science? How do I study engineering? How do I learn all about that? And if you're really interested and if you want to, you could be that next person to go to the moon, or maybe even to Mars. And if you are excited about the moon, I wanted to let you know one more thing. So next slide. There is a worldwide celebration of lunar and planetary science that happens every year around the world. That's why it's a worldwide celebration. And people all over the Earth get together and look up at the moon on one day each year. And that day changes each year. It's always a Saturday in the fall. And we have had hundreds of thousands of people do this all over the world, and we have activities, we have presentations, we have ways to connect with your fellow lunar enthusiasts around the world through social media or through other ways on our website, observethemoonnight.org. But if you're excited about the moon, if you're excited about space, it's a great time to go to your library, have your school organize an event, get together with other people who are excited about space, and look up and learn about the moon together. So I encourage you all to be a part of that. So thank you. I don't know if you have any questions that you want to take from your moderator. Otherwise, I do have a few in front of me that I could try to address. I'm not sure what you prefer.
Andrea, let me give you a few that have come in over the chats. Is that okay with you?
That's perfect.
So a question from Carissa, third grader from Eno Valley. Does it stay dark all night long in space?
That's a great question. So dark is an interesting concept because, of course, it's dark wherever the sunlight is blocked or wherever you're far enough away from a star such that you don't get the light. So daytime on Mercury, for example, when you're right up near the sun, would be really, really, really bright. But if you're on the other side of the planet, then it would be dark and it'd be hard to see, there's not really a substantial atmosphere, so it would just be really dark on the side that's blocked from the sun. If you're out on Pluto and you're trying to think about day and night, well, facing the sun from all the way out by Pluto, the sun kind of just looks like a little star in the sky, not a whole lot brighter than stars outside of our solar system. So dark and light is kind of an interesting question, but anytime you're not facing a really bright star, it would get dark.
That's great, thank you. This is from Griffin, first grader from Creekside. Does the moon have more than 1 million craters?
I have not personally counted them all, but I guarantee you that it has more than 1 million craters.
Excellent.
Craters on the moon can be all the way down to a tiny thing that you couldn't even see with your eye. You'd need a magnifying glass or a really powerful microscope to see the smallest ones. And they go all the way up to huge, almost covering a lot of the moon. The South Pole Aitken Basin on the moon is it is the largest known impact crater in our entire solar system. So everything from hundreds of kilometers across down to microscopic scales, there's definitely more than 1 million combined.
Thank you. This is Amaya. She's a first grader from Southwest. Can you see this? Do you think they can see stars from the moon?
Oh, absolutely. Yes, you can see stars from the moon.
Okay. We've been studying about the L-Cross in 5th grade. In fact, we're actually participating in the Google Lunar X Prize as a junior competitor. But one of our 3rd graders, Justin from Glenn, wants to know, how is there water there if it doesn't rain?
Ah, that's a really good question. So scientists are trying to figure out where the water on the moon comes from. This is an active area of research. And 2 main sources of water on the moon could be from comets crashing into the surface. So you can get a comet that's a really, like a dirty snowball is an analogy a lot of people use. And so it's rocks and dust and ice that if it hits the moon, it can deposit water on the surface. And that surface gets hot and excited from the sun. And those water molecules can actually bounce around on the surface and migrate to the poles where they can collect and be trapped because it's so cold there that they can't escape. The other main source of water on the moon is actually from the sun. So the sun sends out a stream of particles everywhere into the entire solar system, and that stream of particles interacts with the surface, and it can actually break up some of the materials on the surface. And one of the products it can create is water on the surface. So just a tiny little bit, but over time, tiny little bits can add up to something that we could actually measure.
Okay. So as you know, we talked yesterday, we were getting a lot of questions in about astronauts. I told them we'd hold that to part 2. But one of the questions coming in from Cheryl Lakowski's classroom in Michigan is, how long does it take to prepare to be an astronaut? Can you give them like I think they're thinking that they want to do this. And so is it days, months, years?
It is definitely years, but it sort of depends on where you want to get started. So to become an astronaut, you don't walk in the door of NASA and say, hey, I want to be an astronaut. And they say, great, we're going to load you up on the space shuttle and get you to the moon. What you have to do is you really have to start now if you're interested in being an astronaut and study hard and learn, math and science and reading and, biology, anything that you're interested in. We have a lot of scientists that go to the moon. We have a lot of pilots, or not the moon, out into space now. We're not going to the moon right now, hopefully soon, but who go into space, and they have different areas of expertise. And if you're interested in seeing what types of experience they have, you can look that up on our homepage. But we have doctors and we have scientists and others. Teachers even have been able to go into space. So you really start now by being interested in school, staying in school, studying, and then trying out different things that you think would appeal to NASA, like trying to get your pilot's license or something like that. It's not required. I know a lot of people that do not have that. Anyway, then you start training. Once you are accepted by NASA, you have to go through a lot of classes and to find out about the geology. What can you see from the space station, like volcanoes that you can watch erupting from the space station that maybe we can't see here from Earth, and help our scientists out. You have to learn how to take care of yourself in space, take care of the space station, do all kinds of things. So it's definitely a few years that there. I think it's, I'm not exactly sure, it might be a 2-year training process once you're accepted as an astronaut before you would be able to go out into space.
Okay.
But it is a long process.
Yeah, I have one more for you, and then I think you have a few that we sent in. So this one is first grader, Tamir from Glenn. He wants to know how long, or how did that first footprint stay there so long?
So that's a great question as well. The moon does not have a thick atmosphere like the Earth does. It does have an atmosphere. We call it an exosphere, but it's really, really, really thin. And so basically everything can get through it that's coming down to the surface, but things that don't happen in that atmosphere, and the reason that's why we have such tiny impact craters, because there's no atmosphere that causes things to burn up before they get to the surface. But we also don't have any clouds. We don't have any rain. We don't have anything we don't have any plate tectonics like we have on Earth that builds mountains and no water and no weathering. Stuff doesn't break down on the surface because there's just not a whole lot of activity going on. The most that would happen is another impact would get into that footprint and destroy it. And lots of micro impacts have happened to that footprint, but it's still visible because they're so small. But yeah, we just don't have the vegetation and all of those other things that we have on Earth that end up erasing landscapes.
Okay. Well, do you have 2 or 3 maybe you could answer on air? Did you get any?
I did get a few. So someone had asked how long it takes to get from the moon to the Earth, and I mentioned for LRO that's 4.5 days, about 3 days for other spacecraft or for the Apollo astronauts, and even shorter. Someone asked where shooting stars come from, and that is, again, those little tiny bits of rock and dust in space that are flying around that come off of comets as they're going by the sun and they're streaming all these particles off. When those are left out in orbit where the Earth is circling and we cross into that cloud of gas and dust, that material hits our atmosphere and gets really, really, really hot. And then we see that as a shooting star. So it's little pieces of dust and rock from space that make our shooting stars.
Okay.
And someone else asked, why is Pluto not a planet? That's probably a big question a lot of people have. And the reason Pluto is not a planet is not because anything changed about Pluto itself. It's because we found a lot of neighbors that Pluto has that are about the same size, the same type of materials. And it was sort of a question of, well, do we want to have tens of thousands of planets in our solar system? If we call Pluto a planet, then all of these other objects should be planets as well. Or do we want to decide that a planet should be something else, should be bigger, should have cleared its orbit, things like that. And so it was really just a classification decision. Nothing changed about it, but it's so interesting that we just got to go out there because Pluto is now representative of this larger group of objects in the solar system, like the asteroid belt. Same type of idea. We used to have about 30 planets in the solar system at one time, and then we decided, hey, that's too many. There's all these planets in this one spot. Maybe we shouldn't call that a planet. Same thing happened again, where we found all these things in that same spot, and then we decided that probably shouldn't be a planet either.
Well, Andrea, I just want to thank you. In my book, you are a rocket scientist because you've given us a lot of information to think about. We look forward to doing this again with you guys in the near future. I just want to thank Creekside for hosting us today. I want to thank NASA, Shane and Jordan and Mark and Andrea for putting this together, and the team on our end that helped with sound and visual. Our next virtual field trip that's open to the entire country is going to be in February. It will be at Valley Forge, and we're going to be talking about the engineering there. So we'll make sure we put that up. For those of you that watched today, please make sure your teachers or your principals know how great this was so we can continue these. And NASA, you guys rock, ha ha ha. I'm so excited to actually hook up with you soon because I'm hoping to get my Lunar Rock certification. I'm going to start working on that so we can have lunar rocks to look at here in Durham Public Schools. But we thank you again so much. We really appreciate it, and we hope to see you again soon.
Wonderful. Thank you all.
Oh, I didn't show you my, she went off. So I have this great t-shirt that someone gave me that says astronauts need a lot of space. So thank you guys. This is Dr. Drizzle signing out, and we will see you again. And we are here from Creekside Elementary School. Let's hear it, Creekside. We good?